Hello, my dear Chellakutis. How are you, everybody? I hope you people enjoying your summer holidays. சம்மரில் ரொம்ப ஹாட்டாக இருக்கும் உடம்பெல்லாம். ஸோ தண்ணி நிறையவே குடிங்க. அது உங்கள் ஹெல்த் ரொம்ப கேர்ஃபுல்லாக பார்த்துக்கும். Take care. So in this video, what we are going to see in the sense, chapter wise, previous year questions we are going to see. And specifically in this chapter 1, real numbers, most important question which they asked in the board exam, that we are going to focus. So let's see. This is what chapter 1, real numbers, most important question from class 10. Class 10 from 9th to 10th you people moving on, right? So first board exam you're going to face. So all previous year questions once if you go through now, that will be very useful to score more mark, right? Let's start. This is what chapter number 1, real numbers. What is real numbers? First you must know, my dear. Real numbers means what? First you must know. Real number we can divide into two portions. One what we can say, a rational number. What, my dear? Rational number. And this one is called irrational number. This one is called irrational number. Okay, there is a two portion we can divide, right? Rational number we can write into three ways. Okay, one natural number, one more whole number we can write, and integer I will go directly. Okay, what we can go, integer we can write, or else even whole number also we can write. Integer, whole number, these things also. Whole number we should write second, not issue. What is not issue? So natural number means it starts from 1, 2, 3, you know, and whole number it starts from 0, 1, 2, 3. It's okay. And integers means it contain both 0, positive number and negative number. All those things we have. Okay, these everything we can say as a rational number. Rational number in the sense we know that a number is in the form of p by q. Here p and q are belongs to the integer. P and q are belongs to what, ma? Integer. And most important thing is denominator must not equal to 0. That is we know what is rational number. And irrational number. Irrational number in the sense which is not in the form of p by q. A number not in the form of p by q, that numbers we can say as a irrational in simple manner, right? Now let's go to what is rational. Little deeply we can go. So rational means already we have seen in the previous page, right? What we said actually, rational means a number is in the form of p divided by q, where q not equal to 0 and p comma q belongs to integer. Okay, p comma q belongs to what, my dear? Integer. So this is we can say as a rational number, and this one is very important. Example, let's start, ma. If I'm giving 1 is a rational number, even 0 is a rational number. Understand? If I'm writing 3 is a rational number, 10 is a rational number, or 10 by 7 is a rational number, or 7 by 10 is a rational number. So like that you can write. Okay, sir, 0, how it can be rational, sir? You said a number should be in the form of p by q, but 0 which is not look like a p by q, then how we can say is the rational? Listen, 0 you can write 0 by 1, or 0 by 2, or 0 by 100, or 0 by any big number you can give, equal to what? 0. Okay, so that the 0 you can write in the form of p by q, even both numerator and denominator which is belongs to what? Integer. Okay, integer. So that we can say 0 is a rational number. Like that all integer, all whole number you can write divide 1. 1 if you take, I can write 1 by 1 equal to 1. So which is in the form of p by q, I can say rational. Next, 3 you take, 3 divided by 1 I can write. 1 is what is that? Integer. 3 is an integer which is in the form of p by q, we can say what is that? Rational. Same 10 by 1 you can write. Okay, this is C, 10 is an integer, 7 is an integer, and this is also what? Integer. And here the last number you can write even 0.7 if you enter in the decimal format. In decimal also we can write the rational irrationals. Understand? That we will see in the next. Okay, next. So this is the rational. Because decimal, why I said in the next portion we will see now, we can write in two ways. One, terminating. Because when you write in the decimal, that will be stop in somewhere else. It's called terminating. When you divide one number, it will not, what is the terminate? And these things, if you divide, if you convert into a decimal, it never stop. It will continue. Keep on, it's going. So that things is called non-terminating. So terminating, non-terminating, two things is there. In the non-terminating, one more two division. In the non-terminating, repeating, not repeating. The two things we have to say. That means occurring and non-occurring. That you can give. That things we will see in the next topic. Now, rational number in the sense, the number should be written in the form of P by Q. Q not equal to 0. P and Q must be integer. That you have to remember. Understand? Right, pa. So, first chapter if you are going na, about rational number, general idea you should have. Then only MCQs and all you can answer little easily. Right. I told you a decimal expansion we can see in the next topic I said. Now here we have decimal expansion means what? Decimal expansion for a rational number they are given. Let's see here. Okay. Decimal expansion of what? Suppose if I am writing 7 by 10 in the sense 0.7. 0.7. Suppose I have a 10 by 7 in the sense 1 sevens are 7. When you divide 1 sevens are 7. You can divide if you want. 10, 7. 1 sevens are 7. Remaining 3. Give a point. Add a 0. Okay. 3 sevens are 20. 1 or 4 sevens are 28 you can write. 4 sevens are what you can write? 28. 4 sevens are 28. Again what ma? 2. 2. If you add a 0, then 2 sevens are 14. Then what I am getting? 6. If you give a 0, so it will be going on. It will be going on. Understand? 60. Then 8 times 56. Again 4. 0. Understand? So 5 times 35. Understand? 5 you getting 50. If you give again 0 50. 7 sevens are 49. So what I am getting? Reminder 1. Again, if you give 0, what I am getting? 1 sevens are 7. Remaining what? 3. 3 na 30. So again, the same number is coming. So no end. It's going on. It's repeating again and again and again and again and again. It will be repeat. So it's non-terminating but recurring, which means repeating. Okay. So that 4, 2, 8, 7, 1. Again, it will be coming. So this is non-terminating. Non-terminating and repeating or recurring. Okay. Repeating or recurring you can write. Which means what actually I said. So it will be stop 1 over. 2 one more one what na? It will be non-stop. It will be going on. That is called non-terminate. In the non-terminate, there is a new number will be coming. That is called non-recurring. One more one is recurring. Number will be repeat. Okay. So that is I gave here. Repeating number I gave. Or one more number, if you take 22 divided by 7, that is called pi. Generally, pi is equal to 22 by 7. Okay, we know. So if you divide this, you will be getting 3.14. Number never repeat. So this is called non-terminating. Non-terminating. Very important. Basic idea if you know. Okay. And what is that? This is what I said, recurring, and this one will be non-recurring, which means not repeat. Okay, which means what, my dear? Not repeat. Every time you will be getting different numbers. Okay, first one is what? Terminating. First one is what, ma? Terminating. Okay. So 3 ideas we have. Rational. This everything rational number one. This is rational. This is rational. Pi is not rational. Pi will be in the form of irrational. Pi will be what, my dear? Irrational. Okay. So if see, this is rational. These two will be coming under the rational because terminating. If you convert into a decimal, if it is stop, what is that? Rational number. Suppose non-stop it is going, but repeating. What, my dear? Repeating in the sense that you can say rational again. That we can say what, ma? Rational. So these two things we can say what, my dear? Rational. Suppose non-terminating, sir, number is recurring. Number is what, my dear? Recurring. In the sense, this will come under the what na? Irrational. What, my dear? Irrational. Not a rational, we can say, or a irrational, we can say. Irrational, that is the next topic. We'll go. Okay, have you understand now? Rational na, what is that rational form? Sorry, decimal form, we have a two thing. One, what? 7 by 10, which means terminating one. Second one, non-terminating but repeating. Repeating is there now, surely it is called rational. Repeating is not there, sir, and not stopping. It's going on, in the sense that we have to say irrational. Understand? Right. What is irrational number? See, the number which is not in the form of P by Q. Okay. The number is not in the form of a P by Q, where Q not equal to 0, P comma Q belongs to the integer, which is not in the form, very important, not in the form of P by Q. Understand? Example, let's see, Raja. Example, pi, I'll give pi. So pi is equal to 3.14, you can write 1. And second thing, what we can give? Root 2, root 3. See, root 2 and all, you cannot write in the form of P by Q. Sir, some people will say, sir, root 2, sir, divide 1, sir, in the form of P by Q, sir. Then that is correct only, no, sir. Correct, sir, which is in the form of P by Q. But both P and Q must be belongs to integer. 1, okay, integer. Root 2 never belongs to integer. That is what, this is wrong. Must be integer, I said. Okay. So root 2 is not an integer. Root 2 is not an integer. So this will be coming under the irrational. This is something else. 1.414 will be coming. It's going on. This is 7. What is the 1.732? It's going on. So no stop. So one more idea I will give. This is which is not in the form of P by Q. I'm telling general definition. Decimal form na, we have a specific things what in the sense non-terminating and non-recurring. What you can say, pa? Non-recurring. Which means, what is meaning of non-terminating, non-recurring? That you have to learn on, right? Non-terminating means no stop. It will not stop. It will be going on when you convert into decimal. Okay, non-recurring. Non-recurring means no repeat. Okay, no repeat. You will be getting always some new numbers. So these things you must know. When you write irrational number in the form of decimal, so this point important. No, what is that? No stop, no repeat, which means non-terminating, non-recurring in the decimal. Generally in the sense which is not in the form of P by Q. Okay, right. So these things you must have idea, Raja. Then only easily you can learn. Right. Next, prime number. So prime number means what? First you must have idea about a prime number. Prime number in the sense, we have seen this very important thing. A number must have 2 factor. It has only 2 factor. Okay. Simple word we can write only 2 factors. Okay. What all number we have only 2 factors, that we can say prime number. Then what about composite number? Composite number means what? What I said there, opposite, which means more than 2 factor. Okay. Number, what is that? More than 2 factors. Simply we can write that more than 2 factors. Easily you can remember this. Easily you can remember. Prime means only 2 factor. Composite means more than 2 factor. Easily you can remember. Okay, sir. Number 1 I will take, sir. Number 1. Number 1. Starting in the, what is the natural number? Number 1 I am giving. Number 1 contain how many factor? Number 1 factor is 1. Number 1 factor is what, ma? 1. Any other number divisible by 1? No. So number 1 consists only 1 factor, ma. But prime number is what, na? 2 factor. Exactly 2 factor we need. Here only 1 factor. Which one? Number 1. So number 1 not prime. Okay, whether it is belongs to composite, let me check. Now composite, na, that should have more than 2 factor. But number 1 contain 1 factor. So number 1, 1. will not come under prime and composite. Then what it is called, sir? Number one, neither prime nor composite. Okay, which is not a prime, not a composite. Understand? Right, very important. They may ask in the MCQ. Right, come to the point. Prime, next number I'm taking 2. 2 contain what all factors? First, 1 will be a factor for 1, which means 2 by 1 equal to 2. It's dividing. What is exactly dividing a number? It's called a factor, nothing. Okay, right. Then what is that? 1 is a factor. 2 by 2, sir, exactly dividing by equal to 1. Equal to 1. So 2 also one of the factor. Right, sir? 2 by 3, 3 is not dividing. And 4 is dividing, sir, but we are getting something reminder here. It should be exactly divisible, I said. So this is not exactly divisible. So hereafter, whatever number you give, it will not. So number 2 have exactly 2 factor. What? 1 and itself. 1 and itself. Right. Number 3, if you take, so 3 will be divisible by 1. 3 will not divisible by 2. 3 will divisible by 3 itself. Whatever number more than you give, it will not. Understand? So 3 also prime, because 1 and 3 we have 2 factors. 4, if you take 4, number 1 is a factor. 2 also will divisible by, because 4 by 2 is equal to 2. It's divisible. And 4 will not divisible by number 3. Leave it. But 4 will divisible by 4 itself. Always every number will divisible by itself. So that 4 also one of the factor. But the 4 never come under prime, because it has more than 2 factor. 1, 2, 3 factors we have. So you should not write there. We should write here. Then 1, 2 and 4. We have 3 factors for number 4. Then 4 is called composite number, not a prime. We understand? Like that, number 5. Number 5, if I write, 1 is a factor for all the number I said already. Then 5 will divisible by 2, 3, 4, no. So that what? 5 will divisible by 5 itself. Maximum all the number will divisible by 1 and itself. Okay, that number only will come under the prime. Definition that also we can use. What define a prime? A number is divisible by 1 and itself is called a prime. Yes, surely you can use it. Okay, right. So number 5 is a prime. Number 6, because number 6 has a factor 1, factor 2, factor 3, even factor 6. These things is our factor. So we have more than 2 factor, right? Because definition of more than 2 factor now we can say composite number. So and so on. Okay, and 7 will be coming here, 1, 7, 8 will be here, 9 will be here, 10 will be here, 11 will be here. So it's going on. Okay, if you write till 100, you will be getting 25 prime number. This is MCQ. How many prime number we have between 1 and 100? If they ask you have to say 25 prime numbers we have. What, my dear? 25 prime numbers we have. MCQ they may ask. Understand? One more they may ask. Find LCM of first 10 prime number they may ask. First 10 what is that? 2. From 2 to you have to start. First 10 prime number. 2, 3, 5, 7 and 11, 13, 17, 19, 1, 2, 3, 4, 5, 6, 7, 8. Then 23 and 29. Okay, these things like that you can write. Now 10 number. For this they may ask LCM and they may ask HCF. Okay, and I'll give one shortcut. See, HCF if they ask for a prime number, P and Q are prime always 1. Don't forget MCQ answer. They may ask MCQ answer. HCF, what is that? Highest common factor. You have studied already what is highest common factor in 6, 7, 8, even 9th also. Okay, highest common factor for a prime number in the sense 1. And LCM of P, Q, P and Q are prime product of the number. You just product the number. 2 prime numbers given and they asking what is the LCM you product. 2 prime numbers given, they asking HCF equal to 1. Blindly you can give this answer. Okay, right. So this is prime, this is composite. I hope you may got idea what is composite, what is prime. Next theorem number 1. Next what, my dear? Theorem number 1 we have. What theorem number 1? Fundamental theorem of arithmetic. Fundamental theorem of arithmetic. In short manner I will give. Okay. Fundamental theorem of arithmetic in the sense, any number Any composite number you take. Any composite number. Okay. Any composite number you take, Daraja. That composite number can be written in the form of product of prime. Any composite number you take, that what is the composite number can be written or can be make a factorized by with help of prime number. Okay, simple word. Suppose if I am taking 4 now, 4 I can write prime factor, only prime factor. So 2 into 2 I can write. Composite, only composite. 6 I am taking now, 2 into 3, product of prime number. Am I right? Okay, if I am taking number 15, in the sense 3 into 5, any number you take, any number. If you take 100, okay, if you take 100, 5 square into 2 square, prime number. Any big number or small number you take, that composite number can be expressed or factorized as product of prime, product of primes. Product of primes, any composite number is able to write in the form of product of prime. That is called fundamental theorem of arithmetic. Next line. Here there is no order need to follow. For example, so I have mentioned 5 square into 2 square, right? Here you can write 2 square into 5 square also. Here order is not an issue. Order is unique. That can be any descending or ascending, not an issue. That is what next line. And this factorization unique, that will be unique. We cannot give one more factorization for 100. We cannot give, I'm right? We cannot give. If you give also, it will be like a descending or ascending. So that will be unique always, apart from order. Why order? Now only I said, either big number to small or small to big. That's not an issue. That's not an issue. Okay. So in which prime factors occurs. When you write a composite number in the form of prime factorization, one thing, what is that? Product of the prime will be unique and apart from the order. Order, you can write anything. Small number to big number or big number to small number, not issue. So simple word, very important. This they may ask in the MCQ, fundamental theorem, in the sense product of prime number. Product of a prime number. That's it. Right. Next, 1. Check whether 4 power n can end with the digit 0. See, actually this is from previous year question. Okay. Right. Check whether 4 power n can end with the digit 0, they are telling. So, generally, any number is end with the digit 0, what you will be getting. Any number end with the digit 0, now what you will be getting. Suppose number 10, 20, 30, 40, 50, and so on. It's going like 90, 100. Any numbers like that if you have, how we can write? 10 we can write 2 into 5. Okay, 20 you can write 2 square into, what is that? 5. 30 you can write 3 into 10, which means 3 into 10 means 2 into 5 you can write. Like that 40 4 into 10, 4 means 2 square, 10 means 2 into 5 you can write. Same manner 50 means 5 into 10. So that 5 into 2 into 5. Same manner 90 means 9 into 10, 9 you can write 3 square, 10 means 2 into 5. Same manner 10 in the sense, 10 already we are done, then let's take 100. 100 means what is that? 2 square into 5 square. You can note down one point, what is that very important here. See, there is 2 into 5, 2 into 5. In all the points, there is 2 into 5. Have you noticed? Okay, so that any number is ended with the digit 0, the number must be divisible by 2 and 5. That you must have an idea. Okay, that you must have an idea. Right, fine. Let's start now. So here you can write any number, answer. Okay, solution, let's start any number end with the digit 0, end with the digit 0, then it must divisible by, what we can say, 2 and 5. Okay, the number must be divisible by 2 and 5. Right. Now, 5. Here, what is given? 4 power n. The 4 power n must be divisible by then 2 and 5. Am I right? That is the meaning. Okay. So that, but 4 power n we can write 2 square whole power n. That means 2 power 2n. The number must contain 2 and 5, which means must be divisible by 2 and 5. But here we have a 2. There is no 5. That you have to mention here. Okay, that you have to mention here. 4 power n is divisible only by 2, not by 5. Okay, not by 5. Then what we can say that? What we can say that with the fundamental what is uniqueness theorem, there is no other number to divisible 4 power n. Then we can say that which is not possible. Understand? Then with the uniqueness, okay, what is that? Uniqueness, fundamental theorem of arithmetic. Fundamental theorem of arithmetic. There is no other prime. There is no other prime. So 4 power n is not end with the digit 0. Not end with the digit 0, you can say. Understand? Very important here. This line. What is that? Any number end with the digit 0 na, that must be divisible by 2 and 5 is very important line. Next line what? Very important na. With the uniqueness fundamental theorem of arithmetic, there is no other prime. Means other than 2, no other prime. So that no other prime means we need a 5. That is what I mentioned, not a 5. Only 2 I said. So these points are important. After said that, so 4 power n is not end with the digit 0 for any natural number n. For any natural number n. That's it, Raja. So this is actually very, very important to mark. Instead of what is that 4 power n, they may give what is that 4 power n, 6 power n, and 15 power n. Any number they will be giving. Any composite number power n they will be giving. You should ready for that. The very important idea in this question, 2, 5 must be there. Any one number not there also, you have to say no, it's not possible to end with the digit 0. Or else if you want to confirm, sir, I want to confirm the question is end with the digit 0 or not now, you can check like this also. You can check like this. For example, they said 4 power n. N is natural number they have mentioned in the end. So 4 power 1 if you give now, 4 you will be getting. Understand? This is for rough work to understand I am giving. 4 power 2 in the sense 16. Understand? So that 4 power 3 when I give, what I will be getting? 16 into 4, which means 64. So 4 power 4 if I give now, what I am getting? 64 into 4, that will be 256. See, for example, I gave 4 numbers. Here all the numbers, the end point you can see. End point what I got? Either 4 or 6. I am not able to get the digit 0. So through this example also you can understand. With the example also you can understand. Then you should. But these lines are very important. If you write these lines only, they will be giving full mark. This is for only understanding purpose. Understand, children? Right, fine. Next we will start. Question number. Before going questions, we should know about what is HCF, what is LCM. What is HCF, what is LCM? Generally, HCF means highest common factor, that is abbreviation. But definition means, by definition, see, product of smallest power of each common prime factor. Very important. Smallest power of each common prime factor is called the HCF. Example. What example we can use? Suppose I have, see, they are asking HCF of 2, 6 I will take. 2, 6. So 2 prime what? 2 factor. 1, 2. So prime number now only 2 you can. 6 factor what? 1, 2, then 3, 6. Okay. Only prime number. Mean 2 and 3. Only prime number you have to take. Prime number. So 2, 3. So that you can see that 2 is equal to 2 is my prime. 6 is equal to 2 into is my prime. Okay. Then what is my HCF? HCF in the sense what I said, that must be smallest power. you can note down one thing here. There is no 3 in this. There is no 3. Anything power 0, you can say 1 number, right? So that this one you can write 3 power 0. Other numbers 1 1 you can give. Okay. Now see, now you can compare the powers. They said smallest power of each common factor, they said. Common. That number must be common. Then you have to observe the power, least power with the common sign. So 2 is common in both the place. 2 is common in both the place. Then smallest power means there is a equal power. Equal power na the same you take, which is equal to what actually? 2 power 1 multiply. Understand? Now 3 power 0, 3 power 1. There is a common 3 in both the place we have. Power 3 power 0, 3 power 1. What we can say? 3 power 0, 0 is a small, 1 is small, 0. So that 3 power 0, which is equal to 2 power 1, 3 power 0, 1. So that which is equal to 2 is our required answer. So HCF of 2 and 6 na, you will be getting number 2. Very important thing. HCF in the sense highest common factor we know, but the proper definition for this product of smallest power of each common prime number. Okay, so there is a common prime factor or common prime number. In that smallest power you should take and we have to product. Understand? That is the HCF. One more thing. Sir, there is the highest common factor. One word is there, no sir? With help of that also you can go, right? Yes, you can go with help of that also. See here, there is a 2, there is a 6. Okay, now you can write the multiples of 2. Common factor only they are telling. Commonly 2 is there. Okay, leave it. This is extra. You understand the definition? In both the number, common prime number we have to see, and least power, small power you have to take, and everything you have to product. That is I have done. I hope you understand. Next I am going LCM. What my dear? LCM I am taking pa. See, LCM, least common multiple. Generally abbreviation least common multiple definition. Product, we have to product. Product of greatest power. What my dear? Greatest power. There they gave smallest power. Here they are given greatest power. Where greatest power? Of prime factors. Of prime factors. They didn't mention that common. There is a prime factors. Okay. So we have to take greatest power of prime factors involved in the number. There is number I am taking. Same number I will take. HCF is equal to, HCF of 2, 6. So prime number we have, 2 prime is what? 2. 6 prime factorization what? 2 into 3. 2 into 3. Now how we can write? The power must be what? 3 power 0. Other things and all 1. Okay. Now how we are going to take this? Let's see. LCM in the sense what? Product of greatest power they said. Greatest power. So this is common, Maharaja. 2 power 1, 2 power 1. This is common. In that, what is greatest power? 2 power 1 we have a same place now. One time you can take. So 2 power 1 product. Next 3 power 0, 3 power 1. What is the greatest power? 3 power 1. Because 3 power this is small compared to 3 power 1. So 3 power 1 you have to take. So when you product these two, you will be getting what actually? 6. So this is our LCM. This is our LCM. Now one more number. LCM of 2 number I will take. 2 number. What we can take here? 25, 75, 75. This I will be taking. 25, 75. First you should write a prime factorization for this. Prime factorization for 25. 25 we can write 5 into 5 and 75 we can write what is the 3 into 5 into 5. Okay, prime factorization you should write. And what they said first, that must be the 5 into 5 you can write, which is equal to 5 square. Okay, 5 square you can write. Now you can note down that first we have to take product of greatest power when we have a common. So 5 we have here. Here also that is this one you can write 3 into 5 na 5 square. And here also we have what na 5. In both the place there is a 5. And we should take greatest power. Here power is same, 5 power 2, 5 power 2. Okay, then greatest power 5 power 2 or equal power I have taken. Right. Next there is a 3. 3 is not a common. Because 3 is not here in 25. Have you noticed? In 75 we have 3. That is what one more word they gave. Involved number also we have to product. Involved number, which is not common, but one number involved extra. That also you have to product. So what we are telling, product of greatest power of prime and involved number. Greatest power you are taking, you are multiplying. That is one side. Also we should take involved number. Involved number na extra, which is not common. Also like that you can say. So 3 is not common, then 3 is called involved number. 3 is called involved number. 5 square in both the place we have, that is called common prime. In the common prime, greatest power we are taking. So involved number 3 you have to multiply. So that what I am getting, 5 square 25 into 3, which is equal to what now? 75 is our LCM. Understand, this is the LCM, right? One more key point they are given, hint. HCF in the sense what? In common factor, lowest power we are taking. HCF in the sense, in common factor, lowest power we are taking. LCM means what? In common factor, we are taking highest power. That is what I said here. Greatest power, highest power. Smallest power, lowest power. Understand? That is we are using. So this is the key point you must remember. What is the key point? HCF means smallest power and LCM means greatest power. These key point you should remember. Okay, right. One more point what now? When you go HCF, only common number we are taking. In the common number, what is the least power? That we are taking, multiplying. LCM na greatest power we are taking, multiplying, and extra number. Without a common, one number is there, but it is which is not other number. That is called involved number. That is our last line, involved number. That involved number we have to multiply at last also. Understand? LCM and HCF definition, I hope you understand. Let's start based on this sums. So sums in the sense, I'll be given only, what is that? Previous year question I said. Okay, before enter, there is a relation between HCF and LCM. There is relation between HCF and LCM. That, let's see. What is relation between HCF and LCM? See children, let A, B are any two number. Any two number. Any two number I'm taking. For this, HCF and LCM I'm finding. LCM and HCF I'm finding. Okay, these two when you product. HCF of AB and LCM of AB, we are producting. When you find a product value which is equal to the product of the number. Product of the number. This is applicable only when we have two numbers. Three numbers in the sense, not necessary to satisfy this thing. Again I'm telling, or else you can write like this also. What? HCF of A comma B. Only A comma B. And LCM of A comma B. Then equal to same AB when you product, this will be equal. This will be equal. Like this you can say. Suppose, sir, I have three terms, sir. I have 3 terms. So what you will be doing? Let I have what, my dear? 3 terms. Let A comma B comma C are any 3 numbers. Any 3 numbers we have. Right, fine. Then is it possible to satisfy? No. LCM or HCF of 2 number. First I'll write HCF. So HCF of 3 number, not 2, sorry. Multiply LCM of 3 number, which is not equal to A into B into C. Sometime may satisfy. That is what they will be using. Not necessary to satisfy when we have a 3 number. But when we have a 2 number, 100% it will satisfy. Based on this, they may ask question. MCQs they will ask. How is there in the sense? They will give, suppose if you want a LCM, na, product of AB divided by what? HCF. Multiply HCF, when you send opposite, it will be divided. Or I need HCF, then AB is given, then LCM if you divide, you will be getting. Or LCM and HCF is given. Suppose A term is given, B term if they ask, na, multiply A, when you send opposite, it will be divided, then B is standing. Like that you can do for even A also. Okay, so these things you can use in the MCQs. In the MCQs. So this is relation between LCM and HCF we have seen. Based on this, we will see the sums. Right. So question number 2 they gave. There is 2 number 18 and 54. For this, we want to find what? LCM they said. LCM they asked to find here. Right? First you take 18 and 54. The definition of LCM, least common factor, is what? Product of greatest powered number in the prime and involved number. So you must find first prime factorization for the given number. That is necessary. Right? So 18 I'm taking. We should divide by 2 first. Because least prime number in 18 what? That you have to see. Means 18 factor we have a lot. But I'm going to take only the prime factorization, right? So that 2 I'm taking. When I divide by 2 the 18, I'm getting 9. Now in 9, no 2. Because 2 never divisible by 9, I'm right? So the next prime what? 3. 3 is it divisible by 9? Yes. So take 3. 3 3s are 9. So 3 I'm getting. One more 3 now 1. Till you get 1, you should continue. So that 18 prime factor what? Now 2 into 3 coming twice. So that 3 square. Understand? Same manner, let's start the 54 prime factorization. 54 prime factorization. So end with 4 even number means we can go with prime number 2. See, end with even number in the sense you can go with the prime number 2. Right? In 5, how many 2? 2 2s are 4. 2 2s are 4. Remaining 1. 7 2s are 14. So in 54, when you divide by 2, I'm getting 27. So 27, 7 is not what is that? Even number, it's odd. So that it never divisible by 2. The next prime what? 3. 3 is that divisible by 27? Yes. So that 9 3s are 27. Again 3 3s are. Again 3 3s are. Till get 1 you should continue, I said. Now I have a 54 prime factorization what now? 3 coming thrice, 2 coming once. So 2 into 3 power 3. That is my what actually prime factor which I have. Right. Now let's go to find LCM of 18, 54. LCM definition what I said? Product of greatest power in common first. Okay, in common. So this is in common. In the common, I'm going to take greatest power. Power 2, power 3. What is greatest? Power 3. So these you take. So 3 power 3 multiply. Next, this is 2 power 1, 2 power 1. This is also common. Then what is the greatest power? 2 power 1. Because same power, now you can take that, not issue. So 2 power 1. Is that any involved number? Involved number means what I said, which is not a common in both the place. There is no involved number here. Then you can stop. If you multiply these two, that's it, your answer will be over. So 3 power 3 in the same, that will be 27 into 2. When you multiply it by 2, you will be getting, what is that? 2 7s are 14, balance 1. 2s are 4 plus 1 and 5. So that 54 is our required, what actually LCM for the given question. Have you understand? Right, take a note, we'll go to next question. Next, question number 3. Question number 3, what is that? Find LCM 1 and HCF. Then they asking 2 question mark. 1 HCF and LCM. Both we have to find. Question mark and question mark. Both we have to find. Right, find pa. Of 80 and 300. The AB value is given. AB value. A is what here? 80. And B value is what here? 300. Both the terms are given. Okay. By prime factorization method. Method also they have mentioned. So they asked to use a prime factorization method. Right. First, for 80 you should find prime factor. We should find a prime factor. So 2 you take 40. Again 2 you take 20. Again 2 10. Again 2 5. So 5 if you take now 1. Then 80 we can write in the form of prime factorization what? There is 4 times 2. So that 2 power what, my dear? 4 multiply, there is a 5. Right. One more number they gave, 300. The 300 you take ma. Do the prime factorization. 2. Okay, step by step you go, my dear. So that 150. Again 2 in the sense what are you getting? 75 of that. Then 5, number 5. End with the 5 now, you try with the 5. So what it will be? Then 5 means what you will be getting? 1 5 is a 5. remaining to 25 na 5 5s are 15 I'm getting. Again 5 in the sense 3 times. Again 3 na 1. Till get 1 you should continue. Then only you will be getting the proper prime factorization. Okay. So that 300 which is equal to, there is 2 coming twice, 5 is twice. So that 2 power 2 multiply 5 power 2 into 3. So I have given all the prime factorization here. So next we have to find first LCM, then HCF. Both you can find. Right. First LCM they asked to find. Let me go with the LCM. LCM definition. Have you remember? Product of greatest powered number in prime and involved number. So first in common what all prime we have, that you take and see the power. That must be greatest power we should take. So 2 power, what is that? 2 power 4, 2 power 2. What is the greatest power? Either 2 power 2 or 2 power 4. 2 power 4 is the greatest term, right? Then 2 power 4 multiply. Like that. 5. This is 5 power 1. Nothing is there in power, you give 1. So 5 power 1 and 5 power 2. What is the greatest power? 5 power 2. So that 5 power 2 multiply, and the definition says what? Product of greatest powered number in prime and involved numbers. Involved means extra number. The extra number is what here? 3. 3 it is here, but not is here. So 3 is called involved number. The involved number we have to product. Involved number we have to product with the greatest powered number. Okay. If you simplify, you will be getting the answer. That's it. So 2 power 4 in the sense what actually? 2 power 4 means 2 into 2 into 2, 2. 2 is 4, 2 is 4. 4 4 is 16. So that 16 I'm getting. 5 square in the sense 25 multiply 3. So you have to multiply. 16 into 25 means you will be getting 400. Okay, you will be getting what, my dear? 400. If you have it already, you can multiply. So what I'm getting? 30 remaining 3. 5 plus 3 na 8 and 12 balance 1. This is 3. Then you add 0 1 na 400. So 400 you can write. 400 into 3. This 3m. This product only 400. 3 is extra as it is. Now 4 3s are 4 and 3, 12. Then 00 you write as it is. This is my what actually LCM. This is what actually my LCM. And they asked to find also HCF. HCF you can go by either definition or there is a formula. Also you can use. If you want, I will give both. First by the definition. Definition says what? When we have a common, we should take least power, which means smallest power. Product of smallest power in the common prime number. That's it. This is the definition for the HCF. So common prime number what you should find, then small power you have to take. Understand? Right. So this is 2 power 4, 2 power 2 common prime number. 2 power 4, 2 power 2 small number means 2 power 2 multiply. Understand? 5 power 1, 5 power 2. What is small power? 5 power 1. Take 5 power 1. Involved number and all you should not take in HCF. HCF itself what they say is product of smallest powered number in the common prime factorization. Full stop. Okay. That's it. You multiply 2 power 4. 2 power 2 means 4. That will be 5, which is equal to 20. This is with the help of definition method. With the help of definition. And there is a, what is the one formula we have? When we have a 2 number, LCM multiply HCF, which is equal to A into B. This formula also you can use. You can get the same answer. Any one you find, which you feel comfortable. HCF will be easy. Any one you find, with the help of that formula you can bring. First, with the help of LCM, I will find HCF, then I will go. So LCM I have 1200. HCF I have to find, for example, this I don't know. I'm going this method in the sense you have to go like that. And A value what? 80. B value what? 300. How you can cancel? See, 00 cancel. Okay, and same side if you have like that, you can cancel. 1 3s are, 4 3s are, you can cancel. And 1 4s are, how many 4s are? 2 4s are and 0. Then HCF is equal to 20. This is one idea with the help of formula. And one more, what actually? Suppose, for example, only this is. Suppose, first you finding HCF, then you are going LCM, the same formula. LCM multiply HCF, which is equal to A into B. Any one you should find, but from this, any one you should find to use this formula. Understand? Don't forget. LCM I'm going to find because already HCF we got. So HCF is 20, which is equal to A value 80, B value 300. So 1 0 cancel pa. 1 time how many time? 4 time. Then LCM is equal to 4 3s are 12 and double 0. That's it. See, any one if you find with the help of definition, very easily you can crack this. So this question they may ask either in MCQ or 2 mark. Okay, or a 2 mark. That's it. Take a note, ma. We'll go to next question. Next question number 4 we'll see, ma. Find LCM of 40, 36 and 126. They asked to find the LCM, my dear, and they applying the factorization method. They asked to do with the help of a factorization method they asked to use. So first 40 I'm taking, 40 and 36. Okay, little I will go. 40, 36 and 126. For all this, I'm going to take prime factorization. Okay, prime factorization, let's take. Suppose if I'm doing with the 2 na, here 20, again 2 in the sense 10, 2 means 5 and 5 ones are 5 over. Like that here, what is this? 36, if I go by 2 table, so what I am getting? 2 table now what I am getting? 18, again 2 in the sense 9, 3 table if I take 3 these are 9, again 3 na 1. Now let's go with a what? 126. So 2 table if I give na 6 2s are and 3 time. Then 3 if I take 2 time, 1 time. Again 3 if I take 7 and 7 means a 1. So this is the prime factorization we have done. Now we should go with a what? 40 which is equal to how we can write 2 coming 3 times. So 2 power 3. 2 power 3 multiply 5 and 2 coming twice, 3 coming twice. So that 36 I can write as 2 square multiply 3 power 2 and 3 coming twice, 2 ones, 7 ones. So 126 you can write as 2 power 1, 3 power 2 into 7 power 1. That's it. Children, this is the prime factorization we got. Okay, so for finding the LCM, what we have to take? What is that? Greatest power in the prime factorization number we should take. Greatest power. So when you write a greatest power, it must be common for all the 3. Am I right? So 2 is here, 2 is here, 2 is here. So nothing is there, na 2 power 1 will give. So but here 7 is there, here 7 is missing, here also 7 is missing. And 5 here not there, here not there. So first you write commonly all the elements appeared like that. So that 2 power 3 into 3 is not here. First 5 is there, okay. 3 is not here, so 3 power 0. Okay, 7 also not there, so 7 power 0. Is that any mistakes are not? No. Because 7 power 0, 1. 3 power 0, 1. So no change. Then why I am writing like this? Because all the numbers should appear in all the 3. Then it will be very easy to find. That is what. And this also 2 power 2, 3 power 2 and 5 power 0, 7 power 0. Which is not there that you mentioned. All the numbers should appear. Okay. Now 2 power 1, 3 power 2, 7 power 1 and 5 power 0. See, now 2, 2, 2 and 3, 3, 3, 5, 5, 7, 7. All the number we have in all the prime factorization. Now very easy to move. So what we have to find actually, what is the LCM definition? LCM definition is what? Not abbreviation, definition. Definition is what? Product of greatest powered number and involved number. First, product of greatest powered number in common. Suppose if I am taking, what is that? Prime number 2. 2 power 3, 2 power 2, 2 power 1. What is the greatest power for this? 2 power 3. 2 power 3 multiply. Understand? Next number 3. 3 power 0, 3 power 2, 3 power 2. What is the greatest power here? 3 power 2. Okay. Like that. Now next prime number 5 I am going. Here nothing is there, na 5 power 1. 5 power 1, 5 power 0, 5 power 0. So what we can take greatest power? 5 power 1. Okay, like that. And 7 power 0, 7 power 0 and 7 power 1. So 7 power 1 is the greatest power. Like that you have to go. So if I am writing all the prime numbers, see here 2, 3, 5, 7. So 4 numbers are appeared. All the 4 number, if you are making all the 3 places, that will be very easy to go. Understand? Right. Now you multiply, you will be getting answer. So this will be 8, 9, 7 5s are 35. Now this will be what? 9 8s are 72 into 35. If you multiply, that is your answer. Okay. 72 into 35. So 5 2s are 10, balance 1, 35, 36, 3 table now, 2 3s are 6, 7 3s are 21, 0, 12, 1 again, 5, 2. So that what I am getting? 2, 5, 2, 0. Is that our required answer for question number 4? Children, if you are writing like this, this will be easy. Again, I am telling this will be easy. Okay, right ma? Now next we will go to question number 5. Question number 5. Write the smallest number. Children, smallest number in the sense least number they are asking. Least number. Least means what? LCM, least common multiply. Okay, least number. Here also a smallest number which is divisible by both. Both means common, divisible means which is divisible. Okay, common divisible. That means least common divisible means LCM. So LCM for 306 and 657. Okay, so first the two numbers I will take. You will find a prime factorization. Then you will be getting. So first 306 and 657. Prime factorization I am finding. Prime factorization I am finding. If I go with the 2 table, okay, 2 means 15 and 3 time. Now 3 table if I do 5 3s are 15 1 time. Again 3 table now 1 3s are 3 remaining to 7. So 17 I am getting. Till get 1 we should continue I said. Okay. Now next number. What is that? This is what? 6 5 7. So we can go by 7 means 12, 18. 3 table we can go. 2 3s are 6, 1 3s are 3. Remaining 2 means 9 time. Okay. Again it will be 12. 3 table we can go. 7 3s are 21 and 3 3s are. 73 is a prime daraja. So you write as it is. 73 is a prime. Right, fine. So after getting the prime factorization, how we can? Already I said LCM we have to find. Before that, the 306 we can write. 306 how we can write in the form of, so 2 power 1, 3 power 2, 17 power 1. Okay. Like that 657 how we can write? 3 twice. Okay. 3 power 2 into 73 power 1. So how we can represent this? How we can represent? How we can? Means all the numbers should appear in all the, what is the elements of, right? 2, 3, 17 and 73. 4 number we have. So here 2 and 3 and 17 and 73. 73 is not here. So 73 power 0. 17 we have 1 time. 3 we have a 2 time. 2 we have 1 time. Like that you write. Okay. Same manner here. So 2 and 3 and 17 and 73. 73 1 time. 3 2 time. 17 0 time. 2 also 0 time. Like this if you are writing, very easy to find the LCM. Okay. So LCM is what actually? Least common multiply. Abbreviation. Definition is what? Product of greatest powered number in prime and involved number. Okay. So that first 2 I am taking. So 2 power 1, 2 power 0. What is the greatest power? 2 power 1. 2 power 1. Okay. Next 3 power 2, 3 power 2. What is the highest power? 3 power 2, 3 power 2. Same. So any one you take. 3 power 2 multiply. 17 power 1, 17 power 0. Greatest power means 17 power 1. Multiply 73 power 0, 73 power 1. So 73 power 1 you can take. Now you can multiply all those things. You will be getting the required. 2 3s are 6. Sorry, 9. This is okay. 2 into 9 into 73 into 17. 73 into 17. 7 3s are 21 remaining to 49, 50, 51. Then same 73, 1, 4. This is what actually 12. So that 1, 2, 4, 1. 1, 2, 4, 1. This is what 18. So 1, 2, 4, 1 into 9 2s are 18 I said. So that 1 8s are 8. And what I'm getting 4 8s are 32. 32 remaining 3 bar and 2 8s are 16, then 19 balance 1, 8 plus 1 na 9 I'm getting plus 1 4 2 1. So what I'm getting 8 3 and 13 1 2 again 2. Okay, so this is our required answer. 22338 is the required answer for question number 5. Okay, right pa. Next question number 6 will start ma. Question number 6 says what? Find what they are telling, HCF and LCM. HCF and LCM of 30, 72 and 432 using the prime factorization. So both we have to find. First number 30 we have, 72 we have and 432 we have. For all these three number you should find a prime factorization. So first 30 I am taking pa. Let me divide this with the prime number 2. So 15, 3 na 5, 5 means 1 I am getting. Same 72 if I take, what I will be getting? 72 if I take 2 means, so 3, 1 means 6 time I am getting. Then this will be 18. Okay, and 2 means again 9, 3 in the sense 3 times 1. And 432 if I go, what is my prime factorization? 2, 1, 2 2s are 1 time 6, again 2 table in the sense 10 2s are 20, then 8, again 2 if I go 54, again 2 means 27, 3 means 9, and again 3 in the sense 1. Like this prime factor when you take, you must be careful, you should not do mistake. 30 means 2 into 3 into 5, like that. 72 na 2 coming 3 times, so that 2 power 3 multiply 3 power 2, because 3 coming twice, and here 2 coming 1 2 3 4 times pa, means 2 power 4 multiply 3 power 3, 3 power 3. So how you will be writing this? Actually in all the number we have 2 3 2 3, but here extra 5 is there. Then what we can do, here we can write 5 power 0, here also 5 power 0. Then only very easy to go HCF and LCM. First HCF. HCF definition, have you remember? Abbreviation highest common factor, but definition what? Product of smallest powered number in common. See, in the prime factorization, what is common? In that least power you have to product. That's it, least power. So here 2 power 1, 3 power 1 and 5 power 1. What is common? 2 power 1, 2 power 3, 2 power 4. 2 is common. In this least power na what? 2 power 4, 2 power 3, 2 power 1. 2 power 1 is the least power. Understand? Like that 3 power 1, 3 power 2, 3 power 3. Least power what? 3 power 1. So 3 power 1 I am taking. Like that 5 power 1, 5 power 0, 5 power 0. So 5 power 0 is the least. So that 5 power 0, 1 you leave it. What is there? 2 power 1, 3 power 1, 2 into 3, which is equal to 6 is my required HCF. So after finding the HCF, you can go by LCM. Okay, LCM you can go by either formula pattern. Formula is that is also you can use, or by the definition. Definition very simple, that will go. Definition is what? Product of greatest powered number and involved number. 2 power 1, 2 power 3, 2 power 4 na greatest power 2 power 4. Okay, multiply. And 3 power 1, 3 power 2, 3 power 3 na 3 power 3 is the greatest power. Okay, next 5 power 1, 5 power 0, 5 power 0, 5 power 1 is the greatest power. So product of greatest power and involved number, that is the definition. So 2 power 4 in the sense 16, and this one 27 into 5. Okay, so 16 5s are 80. that you multiply, okay. So 380, after getting 80, 27 you multiply. So this will be 0, 7 8s are 56 plus 0 again, 2 8s are 16, 0 6 this is 11, 1 and 2160. What my dear, 2160 is our required LCM and HCF. These two things only they asked to find. Okay, make a note, children. Next we will go to question number 7. Okay. Right. Question number 7. This is like a HCF, LCM. Oh, HCF only they asking. HCF they asking, but with this like a MCQ pattern. Listen, children. This is a PYQ only. If HCF of 85 and 153 is expressible in the form of, so if you find HCF, this will be coming in the form of 85n minus 153, which means HCF equal to 85n minus 153 is the given condition. Then value of n, what is the n value? That is their question. First 85 and 153 HCF you find, then make it equal to here, then you will be getting the required value of n. Okay, right. First 85 prime factorization will find, then you comes to know what. So that 5, 1 5 is a 5, remaining 3 na 7, so that 17 I'm getting, that's it 1. Okay, 17 5 is 85. And 153 if I take, so what is that? 3 table we can go. 5 3s are 15 one time. Again 3 table now 1 3 are 3, 2 if you give now 7 3s are 21 again 17. So that what we can write, 85 we can write 5 into 17, and 153 we can write 3 power 2 into 17. Okay. So we need HCF. HCF means what? What is common? What is common? That you have to take common. Least power number in common. So here 3 is not there. If you want to write in that common pattern we are using, no, that you can write. What is that? 3, 5 and 17. 3 is not there. 5 one time, 17 one time. If you want to write like that, you can write. 3 power 2 and 5 is not there. But we have here 17 first and 5 is not there, na 5 power 0. So what we have a common, that you can see. What is common means 17 power 1 is a common. Here itself you can note down 17 is common. So common only HCF. Common only what my dear? HCF. So that HCF of 85 comma 153 you can say that 17. What my dear? 17 you can say. So after get HCF is 17 na, instead of HCF you can mention 17. Then simplify. So that 85n minus 153. Minus 153 when you send opposite it will be plus, means add with 17. Add with 17. So after adding what I am getting, let's see. If you add na, what I am getting 60, 70, 170 which is equal to 85n. Okay. This will be cancelled by what table? 2 table. Okay. So that 1 time, how many time? This will be 2 time. So n value what I am getting Daraja? 2. Where is my option pa? B. So this 1 mark can take these many steps? Yes, it will take. So you have to work out carefully. Understand? Okay pa. Next we will go to question number 8. Question number 8. If HCF of 336 and 54 they gave 6. So HCF value is given. LCM they asking. What is LCM? For this we can use formula because 2 number is given. HCF, LCM, any one is given. Now you can use formula. What formula we know? LCM multiply HCF, which is equal to product of the number. Product of the number A, B if you take, you can, first number is A, second number is a B. Like that if you take na product of the number in A into B, you can write. Right, fine. Now let's start LCM. LCM we don't know, that is we have to find. HCF is given 6, which is equal to A value 336 and B value 54. If you want to cancel, you can cancel directly or multiply number when you send opposite, what you will be getting? Divide. After sending into divide also, you can cancel, not a issue. Okay. So that this is what actually 1 6 are How many 6 are you will be getting? How many 6 are you will be getting? 54. 9. Okay. Now you multiply. Now you multiply with this, you will be getting the required. So that 3, 3, 6, multiply 9. So that 9 table. Okay. 9 6 are what? 54. Remaining 5. This is what? 9 3 are 27. 27 plus 5, what I am getting? 32. So 3. Again 27 plus 3, 30. So 3024. 3024 is our required LCM. Understand? This they will be asking in the 2-mark question. This is also one of the previous year question. So already we are taking only collection of PYQ only. Understand? This is a 2-mark question. Sometimes they may ask in the MCQ also. Make a note. Okay. Let's go to, what is that? Question number 9. This is they asked in the board 2019 accurately. That is I have mentioned. The HCF and LCM of two numbers. Okay, two numbers 9 and 360 respectively. Listen carefully. Children, HCF and LCM of two numbers are. So that HCF is a 9. LCM is what na? 360 for two number. The two number what? We don't know. That can be A comma B. Okay. Right. If one number is 45, means A value is given 45. Find the other number. Other number means B equal to question mark. So, listen, HCF given, LCM given, one number is given, other number they are asking to find. In the previous question, what formula we used? Same thing we can go. What is that? LCM multiply HCF, which is equal to product of the number. The number, if you are taking A, B, na, so product of the number, you will be getting A into B. So LCM value 360, multiply HCF is a 9 and A value 45, B value we need to find. Multiply 45, when you send opposite what ma? Divide. So that 3609 divided by 45, which is equal to B. Now you can cancel. Now you can cancel. Okay, 1 9, how many 9? 9 5s are, you will be getting. 9 5s are 45. Okay, now this one you can cancel 5 table, right? 1 5, how many 5? 7 5s are 35, remaining 1 na 2 times, 72. So that what is my B value, ba? What is my B value? 72, which is equal to B. That's it. 72 by 1, that is you can write B. Okay, 72 by 1 is 72. Understand? That's it. This is also one of the 2-mark question, also PYQ. Okay, we are asking collection of PYQ only, you know. Right, make a note, ma. We'll go to next question. Question number 10, we are moving. This is like a MCQ pattern. Same model, actually they asked LCM of 32 and A is a 64. Means LCM is given, HCF also given, is equal to what? Which means what they are asking. A is equal to, maybe A is missing here. Okay, A we have to find. A is equal to what? Right, fine. LCM is given 64 and HCF is given 4. So that one number, this is A mentioned, so that this will take B. B value they mentioned 32, then A equal to what? A is equal to what? That is the question. Here A is missing. Right, fine. Now let's go to the formula. Formula, have you remember, children? Formula will go, what is that? LCM multiply HCF, which is equal to product of the number. So LCM is what? 64 they mentioned. HCF is what? 4. And A value, need to find A. B is given 32. If you want to cancel, you can cancel directly. 132 2 times. Directly you can cancel. So that what I am getting the A value, what I am getting the 2 4s are 8 is equal to A. So that my A value what pa? 8 is the required answer. Understand? That's it. Now we'll go to question number 11. Right, fast pa. Question number 11. Can two number have what is there as their HCF and 380 as their LCM? This is different question, ma. Actually, very important model also. Sometime they will be asking this. Already they asked one of the year. So, can two numbers, the two numbers, let's take A comma B. A comma B can have 16 as their HCF. Question mark. So 16, HCF is equal to 16. Is it possible for A comma B? 1. And 380 as their LCM possible. Question mark. LCM is equal to 380. Okay, this is question mark. Is it possible? Is it possible? This is possible or not? Give reason. Generally, children, HCF always factor for LCM. That you must know. Okay, whatever the simple number you take. Suppose 2, 4 if I am taking na, HCF what pa? 2. LCM what ma? 4. So the HCF will be divisible by the LCM. Accurately it will be divisible. Remainder 0 you will give. So always HCF is a factor for LCM. That you must know here. Okay. So first you check the HCF is a factor for LCM. Yes, in the sense, yes, this is possible. Suppose not dividing accurately in the sense, no, this is not possible. That is you want to do. So you can write the answer. You can write the answer. We know that, what is that? Generally, or we know that, we'll write directly. We know that HCF is factor of LCM always. Okay, always. That you must know. HCF is a factor of LCM always. Here means in this question, 380 divided by 16, you should check whether is it dividing or not. Okay, let's check ma. Let's check here. 380 divided by 16. If you do now, what I'm getting? 2 times 32. Remainder what Raja? 6. 60. So 16 you cannot get. I think 5 if you give also 50. 5 no, not 4. 4 will give. So 4 16s are what pa? 64. It's crossing. Then 3 times 3 na 48. Remainder what I'm getting? 12. This is 2 and here 1 12. So remainder I'm not getting equal to 0. Remainder if you not get, actually you want to give point, then only you should continue. Remainder not equal to 0. Remainder not, this is coming 23 and remainder 12 is there. So this is and all you don't want to show. 23 point something. So what you here 380 by 16 is not divide exactly. That you want here 380 or else here HCF equal to 16 is not factor of LCM is equal to 380. So given HCF LCM are not possible. Write your own answer, Raja. But explanation you have to give clearly. The reason is what? This is the reason. This is the main reason you want to give. That you want to explain here. Then steps and all you can give your own steps, not an issue. HCF must be factor for LCM. Here not satisfied. So this is not possible. Simple. 2 more. Simple 2 more. Easily you can get. Reason they asked. This is our reason. This is our reason. Okay. Right, fine. Next question number 12. Let's go, Daraja. 12. This is also one of the board exam they asked. The exponent of 5. Exponent means what, ma? Exponent means power. Exponent means what, Raja? Power. Exponent of 5 in the prime factorization 3750. Just power. What is 5 power? That is the asking. So just prime factorization you want to find, ma. That's very simple. 3750. Just find a prime factorization. First 2 table, pa. So 1 2s are 2. Remaining 1, 8 2s are 16, balance 1, 7 2s are 14, balance 1, 5. Okay, be careful. Again 5 table, 3 5s are 15, remaining 3. And 3 means what you will be getting? 37. In 37, how many 5 will be getting? 7 5s are 35, remaining 2. 5 5s are 25. Be careful. And one more 5 na. What is the 7 5s are 35, remaining 2, 5 again. Again 5 means what? What is that? Is that 1 5 remaining to 15. Again 5 if we go na 3. Again 3 na, okay, 1. So what is the prime factorization for this? 3750 you can write in the form of 2 coming only one time, 2 power 1, and 5 coming 1, 2, 3, 4 time. So into 5 power 4 multiply 3 power 1. Only 5 power what they asked. Only 5 power what they asked. So 5 power 4. Maybe option here wrong. They have given 1, 2, 3, 4. Okay. So 5 power 4 you have to click, which means option D is your required answer. Understand? Only exponent of 5 they asked. Exponent means a 5 power what? 5 power what? 4. So 4 you have to click here. 4 you have to click. Have you understand? Right, ma. Next, the continuation I'll give in the next video. Thank you, children. Take care. Bye. See you later. If you wanna like more videos like this from 10th standard, kindly share this video or like the channel, subscribe the channel. Thank you, children. Take care. Bye. See you later.